Hi, hello everyone. This is Nepalidi sir from ANR Academy. Today we are going to discuss about the problems based on Newton's power sum. In the last year 2025, you have a question based on Newton's sum. Particularly, this topic is interlinked with theory of equations. Let us discuss Newton's sum as well as application problems today. Suppose the questions are of the form: if there is a second degree equation ax square plus bx plus c equal to 0 and it has two roots alpha comma beta such that its power sum, suppose defined by Sn equal to alpha power n plus beta power n, then you have Newton power sum formula as1 plus b equal to 0, as2 plus bs1 plus 2c equal to 0, also as3 plus bs2 plus cs1 equal to 0, and so on, as4 plus bs3 plus cs2 equal to 0. We follow Newton's power sum. Using this, you can handle the problems based on second degree whose power sum related by this model Sn equal to alpha power n plus beta power n, or sometimes the questions may ask in the form Sn is p into alpha power n plus q into beta power n also. And for these type of questions, we follow Newton's power sum in this way. Suppose that if there is a third degree equation ax cube plus bx square plus cx plus d equal to 0, and suppose it has three roots alpha, beta and gamma, and suppose that power sum related to Sn p into alpha power n plus q into beta power n plus r into gamma power n. Then we use Newton's power sum. The formula as1 plus b equal to 0. The first relation is same. Next, as2 plus bs1 plus 2b equal to 0. Then as3 plus bs2, this is not 2b, this is 2c. Next, as3 plus bs2 plus cs1 plus 3d equal to 0, and then we follow as4 plus bs3 plus cs2 plus ds1 equal to 0, and so on. We get as5 plus bs4 plus cs3 plus ds2 equal to 0. So we follow Newton's power sum using these relations. This is the relation of power sum Sn. And here observe, you can remember these two results when second degree equation is given. First, here coefficient 1 into b and then s1 into a. Next, here we follow 2 times of c. Next, s1 multiplied by b and s2 multiplied by a. And after that, these are different. They are of same type. Just in place of x square, x and 1, you have s1, s2, s3, s2, s3, s4. Successive combination you will get. And here, these three are different. You can easily remember that 1, s1, only AB combination. Next, 2, s1, s3. Next, 3, s1. This is not s3, s2. Here it is s2 and it is s3. And after that, the combination is different. You can easily remember from this onwards. A, B, C, D, here the coefficients in the third degree, and you have successive powers S1, S2, S3, S4, S2, S3, S4, S5. In this way we follow Newton's power sim. I am going to prove the relations between S1, S2, S3 as well as A, B, C with the help of differentiation. Let us see the proof. Suppose that there is a second degree equation. If you have ax square plus bx plus c, it is equal to 0, and assume this as function of x. And suppose if it has two roots, alpha and beta, it can be rewritten as a into x minus alpha into x minus beta equal to 0. Now I am going to write its derivative f dash of x. X square derivative 2x, so that first term 2ax, next x derivative 1, so that you will get just b. If you apply logarithm to the function f of x, I am going to use this one. You will get log of a of x minus alpha multiplied by x minus beta. Now, if you differentiate with respect to x, we get log f of x derivative 1 by f of x and its derivative, internal part derivative f dash of x. It can be rewritten as log a plus log of x minus alpha plus log of x minus beta. On differentiation, it is clearly constant derivative 0. Next, plus log x minus alpha, its derivative 1 by x minus alpha, and the last term log of x minus beta, its derivative 1 by x minus beta you have. Therefore, I can write f dash of x as f of x multiplied by 1 by x minus alpha plus 1 by x minus beta. In the denominator part, suppose if I take common x, what happens? Observe. I am going to take common x here. 1 minus alpha by x it is. Next, plus 1 by, taking x common, we get 1 minus beta divided by x. So from this, I can write the value of f dash of x as f dash of x become f of x whole divided by x. Here, taking out x, inside the bracket we get 1 minus alpha by x whole power minus 1 plus 1 minus beta by x whole power minus 1. Now, with the help of binomial expansion for these two, in the next step I am going to apply binomial expansion, binomial theorem. 1 minus x whole power minus n expansion I am going to use. What happens in the next step? Observe. That is, f dash of x become f of x divided by x multiplied by, observe here, 1 minus x whole power minus 1, n value minus 1 is there. You know the expansion 1 plus x square plus and so on, right? Here you have 1 by 1 minus alpha by x, 1 by 1 minus alpha divided by x it is. Next 1 by 1 minus beta by x. On expansion it is clearly here you have f of x by x. Now expand this, 1 plus alpha divided by x plus alpha square divided by x square plus alpha power 3 divided by x power 3 plus so on. And next expansion of 1 by 1 minus beta by x, that become 1 plus beta divided by x plus beta square divided by x square plus beta power 3 divided by x power 3 plus and so on. In the next step, f dash of x become f of x whole divided by x multiplied by 1 plus 1, that is 2. Next here you have alpha plus beta whole divided by x. Next plus, next combination alpha square plus beta square divided by x square. And then you have alpha power 3 plus beta power 3 divided by x cube plus and so on. You know that the notation for Sn, alpha power n plus beta power n. Using this, you can simply write in the right part f dash of x equal to f of x divided by x multiplied by 2 plus, here it is s1 by x and this is s2 divided by x square and then s3 divided by x cube plus so on. This is the result. Replace f of x with ax square plus bx plus c and f dash of x with 2ax plus b. Then what happens, observe. Left hand side f dash x, that is f dash of x 2ax plus b, that is next f of x divided by x, that is 2 by x into f of x, first term 2 by x, f of x, that is second degree ax square plus bx plus c. Next plus sign and observe s1 divided by x square into f of s1 by x into f of x. Next, that is s1 by x square, x into x. Outside you have x square, product of these two x square. Outside you have x. s1 divided by x square into f of x. F of x clearly ax square plus bx plus c. Next, s2 divided by x power 3. s2 divided by x power 3, it is multiplied by f of x. F of x clearly ax square plus bx plus c. Next term s3 divided by x power 4 multiplied by ax square plus bx plus c and so on. Now comparing on both the sides, you will get the relation. If you simplify right part, 2ax plus b become, here it is 2ax plus 2b plus c divided by x. Next plus as1 and then you have here bs1 divided by x. Next cs1 divided by x square On continuation, A S2 divided by x plus B S2 divided by x square plus C S2 divided by x cube plus A S3 divided by x square plus B S3 divided by x cube plus C S3 divided by x power 4 plus so on. You will get this result. First I am going to compare constants. Here you have constant b, here constant 2b, here you have a(s1). So from this I can write a(s1) plus b equal to 0. This is result number 1. The same result you got, a(s1) plus b. Here a(s1) plus b equal to 0. Whether it is second degree or third degree or fourth degree, the first relation a(s1) plus b equal to 0. Sum of roots minus b by a. S1 indicates here alpha plus beta if you select this one, right? Next, see, in the next step, if you compare 1 by x terms in the left hand side, there is no 1 by x term, and here you have 1 by x terms, C, bs1, next here as2, that's all. So that I am going to write as2 plus bs1 plus c. There is no 1 by x term. This is the result by comparing 1 by x multiples. We get this result. This is result number 2. And in the same way, if you compare 1 by x square multiples, you have here as3, next bs2, cs1 equal to 0. On continuation we get as4 plus bs3 plus cs2 0, as5 bs4 cs3 equal to 0, and so on. So this is the result by Newton's power sum, and using these relations we can easily solve the problems which are asked in entrance examinations. And remember, here suppose there is a fourth degree equation. If you have ax power 4 plus bx cube plus cx square plus dx plus e equal to 0. Also you can simply write, without doing all these, without differentiation, without comparison, you have to remember the technique for Newton's power sum. First you have to write as1 plus b equal to 0 when Sn is of the form alpha power n, beta power n plus gamma power n plus delta power n. Okay, then you have to write as1 plus b equal to 0. Next, as2 plus bs1 plus 2c equal to 0. Next, remember as3 plus bs2 plus cs1 plus 3d equal to 0. And next, as4 plus bs3 plus cs2 plus ds1 plus 4e equal to 0. Up to here you have to remember that coefficients from right to left, 1 s1 it is, next 1 s1 s2, sorry it is 2, next 3 s1 s2 s3, 4 s1 s2 s3 s4. In such a way you have to remember the coefficients. After this, next relations are very easy. A s5 b s4 C S3 plus D S2 and for E S1 equal to 0. It continues. So in this way you have to remember Newton's power sum. Let us discuss the problems based on it. Suppose the question, if you have alpha beta are the roots of 2x square minus 5x minus 9 equal to 0 and Newton's power sum having the relation pk equal to alpha power k plus beta power k. Here Sn is given as pk, that's all, and you have to find 2 times of p10 minus 9 times of p8 divided by p9. Let us see. If you have 2x square minus 5x minus 9 equal to 0, here the least one is p8 compared to p9, p8, p10, least index p8. That you have to write here. Minus 9 multiplied by p8 minus 5 multiplied by p9 plus 2 multiplied by p10 equal to 0. This is by the Newton relation. You have here, when it is of second degree, let us observe, this is the relation, right? For ABC, successive terms S1, S2, S3, S2, S3, S4 you will get. So in the same way, you can write in place of S8, S9, S10, here you have the notation P8, P9, P10. The coefficients are same, 2 minus 5 ABC, they are coefficients here, 2 minus 5 minus 9. And from this, 2 times of P10 minus 9 times of P8 written as 5 times of P9. On dividing each term with P9, you will get 5 is the answer. So simply you can solve this question. These type of models asked in JEE mains as well as in advanced examination also. Let us discuss another question. Here you have alpha, beta, gamma are the roots of third degree equation, but here the relation you have alpha power k minus beta power k minus gamma power k. Already we discussed, whenever Sn is p into alpha power n plus q into beta power n plus r into gamma power n, whatever the coefficients here, not only alpha power n plus beta power n plus gamma power n, multiples any real numbers. In such case also, in Newton's power sum, you have the relation, suppose third degree, if you have ax cube plus bx square plus cx plus d equal to 0, then you have not first 4 relations, and for remaining relations, when you have multiples p, q, r, it satisfies. See, previously what we discussed, first 4 relations, when you have coefficient 1 plus 1 plus 1 plus 1 here, then first 4 relations are these. When you have multiples p, q, r like that, then you have to, then if the coefficients are other than 1, other than unity, if you have real numbers, nothing but positive numbers, negative numbers or fractions, whatever you have, then from this onwards the relations are true. Not first 3 to 4 relations. Since it is 4th degree, first 4 relations doesn't satisfy when the coefficient is not unity. If the coefficient is unity, then these 4 relations also continuously you will get these. When you have coefficients, some real numbers, not first 4 relations, from this the relation satisfied by Sn when it is having coefficients real numbers. Okay. Now let us see the last one. You have third degree and coefficients are not unity. 1 minus 1 is there. But here the least one you have P9, least identity. Whenever it is of the form 8x cube minus 6x square minus 4x plus 22 equal 0, replacing here 1 with, here you have 1 with P9, and here you have to replace x with P8, and here you have to replace x square with P9 and here it is with P10. Okay, 9, 10, 11, 12 you have. Yes, here 10, not 9 here, it is 11 and here it should be 12. Here the index increases, right, from right to left, P9, P10, P11, P12. Okay, now 8 P12 plus 22 P9, this is equal to 0. So that it can be written as 6P11 plus 4P10. On dividing each and every term with 6P11 plus 4P10, here 6P11 plus 4P10 on both the sides if you divide, it gives the result 1 and hence it becomes 1. This is the way of handling problems based on Newton's power sum. Thank you so much.